right, so here's the example. Integral of x squared 1 over x squared minus 4. So if you had an x on top, it's probably easy. You don't, so what do you do? So we resort to a different idea. We say, as is often the case in mathematics, when we encounter a roadblock, you ask yourself, can I rewrite it in a different way? For example, 1 minus sine squared is the same as cosine squared. So that's maybe easier to deal with. We rewrite things quite often. So here's what I will do. I'm going to try to rewrite this, totally forget about the integral sign. And I'll say that 1 over x squared minus 4 comes from two different fractions. For example, 5 over 6 comes from 1/2 plus 1/3, correct? So I'm going to decompose this fraction into two partial fractions. So we're going to extract and pull apart and see what happens. So anybody know what my denominators would be? Right? The deal is we don't know what sits on top. No, it wouldn't work out. So what we're going to do is we're going to go through the process of adding these together. If we were going to add these two fractions together to get this, the common denominator ends up being x squared minus 4. So therefore, we have to multiply the top and bottom by what? This side by x minus 2, top and bottom here by. So I get a times the quantity x minus 2 plus b times the quantity x plus 2 is equal to, and that's all going to be over x squared minus 4. So baby steps for the first problem. Anybody questions how I came up with that expression right there? Okay, are the denominators the same? So therefore, I just have to make the numerators the same. A times x is ax. Now we pause. Ax plus bx. There'll be numbers here for a and b. When we combine ax and bx, because those are like terms, how many x's do we end up with up here? There are no x's, are there? And what is the value of our constant? 1. You have no x's up here, and you have 1 for a constant. So therefore, when you combine ax plus bx, you get 0x. So that tells us if a is 2, then b would be negative 2. If a was 5, b would be. If a was negative 1/3, b would be. Right, so we know that a plus b is equal to 0. This is just a system. So now we will look at our constant, though. When we take negative 2 times a and add it to 2 times b, we should get in fact, if you look at the work that I have right here, you can see that I do in fact have systems right here. So this is what we taught in basic algebra today. So when you learned it, little did you know that you would be using it for calculus partial fractions. It's pretty cool. So how do I solve this system? Elimination or substitution? What's easier here? Elimination. I multiply through by 2. And I still get 0. Add those together. And the a's cancel. I get 4b is equal to 1. So therefore b is 1/4. At the beginning, we said a plus b is 0, so therefore a is equal to negative 1/4. So that the negative 2a and positive 2a would go away. Yes. Okay. Good question. Thank you for asking, because this is often a piece that people miss. So watch this if you missed it. This is my x term. And that's my x term. And that has to equal that x term. A times x, b times x, and I have no x's. There aren't any x's up there. So the coefficient in front of x here and the coefficient from x here have to add up to 0. And then those will give me my 1. Negative 2 times, so if you just do it, negative 2 times negative 1/4 is a half, and then 2 times positive 1/4 is a half, and those add to 1, don't they? Okay, so we use this to come up with this system. We combine together, we get b is 1/4, a is negative 1/4. So then we can rewrite the integral. The integral is now going to be, so if we look at the beginning here, it says that a sits over x plus 2. So I put in a negative 1/4 for a, and I put in a 1/4 for b. Instead of putting it up there and dealing with a complex fraction, I just like to always put it out front. It's much easier in that scenario. So I'm going to put a negative 1/4 times 1 over x plus 2 plus 1/4 times 1 over x minus 2 dx. Yes. It does. Yep. Negative 2a plus 2b is equal to 1, because a is negative 1/4 and b is positive 1/4. Get a half plus a half is 1. Yep. It's okay. Now, this looks like a really complicated logarithm. I'm sorry, I gave it away. Integral. It's really actually quite easy. Don't write it down, but I'll just show you. Okay. Forget about the constant. The constant just comes along for the ride when we take the antiderivative, right? So all we need to do is take the antiderivative of 1 over x plus 2. Well, the integral of 1 over x plus 2 dx, you would set u equal to x plus 2, so du is equal to dx. Well, that's all I have is a 1 dx. So therefore, I have the integral of 1 over u du, which is natural log of whatever u is. So that was easy, right? Yes. So very, very easy. So now, as you look at this, I have the antiderivative of 1 over x plus 2 will just be natural log of x plus 2, and then we attach this negative 1/4. And again, sometimes they will make sure to write the absolute value. Note that you cannot take the natural log of a negative, okay? Yes, some of your professors will demand that you do it. It depends on the domain of this, whether or not you can even come up, or the range, whether you can come up with a negative value anyway. I'm not too worried about it. To be on the safe side, I always put an absolute value sign. Plus 1 over 4 times the natural log of x minus 2. So we found the antiderivative. This is the integration technique. So now you understand that when I was in college and the TI-92 came out, that calculator came out, and people said, what's so great about that calculator? And people said, it can find antiderivatives. Like, oh, oh, okay, that's really cool. Yeah. We just did. That's an 84. You do not have a 92. Uh, the natural log part, natural log of x plus 3. So you would put absolute value here and here, here and here. Okay. Okay. All right. We'll go through this example more quickly because you now get the idea. All right. Again, I gave this example to you. If u is equal to x squared minus 9, then du is 2x. You have a 2x, but you don't have the plus 3. Shoot, substitution doesn't work. We're up a creek. We don't know what to do. Well, thank goodness that our teacher taught us how to do partial fractions. I know that I can rewrite this because I have 2x plus 3 over x squared minus 9. I'm going to decompose it. I will see the two partial fractions that it comes from. I have a over what? X plus 3 minus, or plus b over x minus 3. If you switch those around, it will come out to be the same answer as well. You can do a over x minus 3. It doesn't matter. All right? And so now I want to just say, well, if I were to combine these together, what would I do? I'd multiply the top and bottom by x minus 3, and then b times x plus 3. And that's going to be all over x squared minus 9. Equals 2x plus 3 over x squared minus 9. So now the denominators are the same, so we have to make the numerators the same. So ax minus 3a. So I just distribute it through so I can get an idea of what I'm going to have, plus bx plus 3b equals 2x plus 3. So how is this problem different from the other one? We actually have some x's. So I'm going to look at my x terms. And so ax plus bx has to combine to make 2x. So therefore, a plus b has to equal 2. It could be negative 1 and 3. It could be negative 2 and 4. It could be 1 and 1. It could be 1/10 and 19/10. I mean, who knows what it is? We don't know. This has an infinite number of solutions to it. So we create, since we have two variables, we need two equations, a system. So we now combine these in order to get that. Multiply top through by I know that a plus b was 2. So if b was 3/2, then a is 1/2. So I'm going to plug these back in. A is 1/2. B is 3/2. So I have the integral of 1/2 times the quantity 1 over x plus 3 plus 3/2 times 1 over the quantity x minus 3 dx. So by doing that, I didn't find the antiderivative. I just found a new way to write the integral so that I can now find the antiderivative. What is the antiderivative of 1/2 times 1 over x plus 3? 1/2 natural log of x plus 3 plus 3/2 times natural log of x minus 3 plus constant. Booyah. Okay. Here's the catch. Well, we can use substitution here. That's not that big of a deal in this scenario, but here's the question, you guys. If you have a term that repeats itself, so that's totally different. So if you have like, 3 over 16, that could be something, so is that something over 16 plus, something over 8? Or was it something over 4? or is it was something over 2? What was it that we pieced together to get that 3/16? See, totally different, isn't it? And we've also only looked at times where the power in the numerator is lower than the power in the denominator. What if they're the same, or what if they is greater? What if it's greater? And third of all, what if the denominator does not factor? So there are really 4 tiers of partial fractions. The fact is, we are just looking at tier 1. Can I do it? Yes. And you will be able to too someday. I'm more concerned that you guys can't pass your final exam unless we get through this material, so. Wow. All right. This is a great problem because if u is equal to x squared plus 5x, du would be 2x plus 5. And if you look at this 2x plus 5, it's actually not that far off from what I have there. If you just factor out a negative 1/2, you end up with negative 5/2. I'm sorry, negative 10. Negative 10 minus x. That's what you get if you factor out negative 1/2. Well, I've got the minus x, but instead of a 2, I've got a, I end up with a negative 10. So substitution, again, is very powerful and works very well in a lot of situations. But here, it does not help us out. So you really just have to resort to partial fractions. And you might say, shoot, got to do partial fractions. Thank goodness that we have partial fractions. Otherwise, you wouldn't want to do it. So a over x plus b over x plus 5. So I have a times x plus 5 plus b times x all over x squared plus 5x equals 2 minus x over x squared plus 5x. Distribute. Thank you. Therefore, a plus b is? What's my second one? 5a equals 2. Yeah, it sure does. Divided by 5, a is 2/5. So b is negative 7/5. I go back up. A is 2/5. B is negative 7/5. Rewrite my integral. Oh, positive 2/5. Now, I mean, you know, you got the natural log of x plus 5. And what if it was a 2 down below or something else? You know, you'd have to do some substitution. You know, we can make these problems a little bit difficult, but I just, like I said, I just want a one-day lesson like you see it. And that way, if you see it again, you're like, oh yeah, I've got a frame of reference. Then could you go to step 2, 3, and 4? Well, sure, this is generally the most difficult part. You try 4 on your own. I'm tired of working. You guys do some work. You do some work. Okay, you practiced. That should be your answer. Get it? All right. Did you come up with this? A plus B is 2, and 2A minus 3B is what? What do you have? -1? You could also have, or you could have -3A plus 2B is -1. It doesn't matter. So, as long as you have one of those, chances are you made a small mistake here. If you multiply top through by 3, so everybody should multiply through by 3, and we get 5A is equal to 5. Yep. Then A will be equal to 1. Yep, that's fine. Okay, so your setup was A over x plus 3, or x minus 3, plus B over x plus 2 is equal to 2x minus 1 over x squared minus x minus 6. So you have to plug in 1 for A and 1 for B. So it's a very simple substitution now. 1 over x minus 3 plus 1 over x plus 2 dx. Yep. So I decomposed it. So we got natural log of x minus 3 plus natural log of x plus 2 plus constant. Done, done, and done. Yes. You're just going to take out an x. You can't take out a 2x. Yes. Just one of them by 3, the top one by 3. Okay, so I have 4 problems for you. These 4 right here, okay? And that's it. So I'm on a scratch sheet of paper. I actually have time to finish a couple of them. And your last calculus assignment ever. Well, just out of curiosity, raise your hand if you see a Calculus 2 class in your future. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we got about 11. Raise your hand if you know that this is the end of your math career period. 1, 2, 3, 4, 5. Raise your hand if there's a good chance that you will probably also need to take statistics eventually. Okay, so Sam, any thought on majoring in mathematics? Yes? There's at St. Olaf, you could not have a minor or an emphasis in math. You were a math major or you were not. You can have you can have an emphasis. You can major in mathematics and an emphasis in statistics. You can have a major in mathematics and have an emphasis in algebra, meaning abstract algebra. You can have an emphasis in analysis. So there are some options. Yes. Good luck.